So, good morning, everyone. This is Kunal here again with yet another example uh, to showcase the use of Raptor for building basic logic. Now, the reason why we are doing this kind of exercises is so that you, as a beginner with programming, starts to understand how to build your logic. If you do enough uh, problem solving with these type of basic uh, questions, you will slowly start building the logic that would be required to then write more complex programs. So we'll be doing this exercise as part of our series on Raptor. We'll be using Raptor. We haven't started with any programming language yet. I'll be doing a separate series for that once we get a hang of Raptor and we do enough problems using Raptor. So the question I chose for today is to check uh, whether a given number is an Armstrong number or not. So we will be writing a flowchart which checks if a given number is an Armstrong number or not. And an Armstrong number is defined to be a number whose sum of digits raised to the power of the number of digits is equal to the given number. So the number of digits in a given number, let's say if it is n, then individually each digit raised to power of n, if you add that up, should be equal to the given number. And as an example, we have taken 153, which has three digits. So if 1 cube plus 5 cube plus 3 cube, that is basically 1 to the power of 3, 5 to the power of 3, and 3 to the power of 3. If it is equal to the given number, that is 153, then we will say that 153 is a Armstrong number. Another example for a four digit number, of course, is 1634, because 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4 is 1634 again, and therefore it is an Armstrong number. Now we want to write a flow chart which basically checks if the given number is a Armstrong number or not. So let's dive into Raptor right away. So here I am. Let me save this file as Armstrong. All right. So to solve this, it is clear that I will have to perform two operations. The first operation is to calculate the number of digits in a given number, because I will need to calculate the number of digits, because I will use it to further in my program to uh, extract individual digits, raise it to that power, and then do a summation basically and see and check whether it is equal to the given number or not. So let's begin. Let's take an input. So that input could be anything. So as usual, I have selected input box, and I'll prompt the user to enter a number. So enter a number, and just to be more uh, uh, clear, let me write enter a number to check if it is a Armstrong number or not. And let's say we store that in, say, num. All right. So I am storing that number, and I'm using a variable num to store the input number. All right. Next, I want to check the digits. How many digits are there in that number? And to do that, Now I can either do it here in my main program, or I could write a separate function to do that. And it's always good to be modular in your approach whenever you're programming. It's good to break up a bigger problem into smaller ones. Try to create a function wherever you see that there could be repetitiveness in the process. Here, of course, counting the number of digits for various inputs would be a repetitive process. It would make more sense if we create a function around it. So let's do that. So I'll say add procedure. The procedure name, let me say uh, digit count or count digit count. It will take a number as input parameter, and it will output the result as D or digits. So the input is the number, and let me change that to N. So I have created a function which takes input number and it counts the number of digits. And for counting, it's very simple. What I will do here is I will use a counter CNT, or let's say digits, digits, and I will start with 0, and I will do a for loop, and I will continue till n is 0. And there's two more operations that I will perform here. One, I will keep reducing the digits. So the way to do that is I will assign n to floor of n by 10. The reason I do that is because, and let me write that in a comment, because n by 10, or rather floor of n by 10 will uh, reduce or remove the last digit from given number. And I have explained that in a previous video. So let's say if the number is 1, 2, 3, and you divide it by 10, the result will be 12.3, and floor of 12.3 is 12. And this process continues till n becomes 0. So uh, till n becomes 0, this loop will continue, and all I will do here is just increment my digits. So I'll say digits is nothing but digits plus 1. All right. So it will basically count how many digits are there. And if you want, you can quickly put a output box here just to check if your answer is correct or not. So in the output, let me say BIGI digits. Let's check for a couple of values so that we know we are correct. So let me use the call function. I will call the digit count function here, and let us see if we are right or wrong. So let me put 10 here. 10, and let's say I need the output as B. Let's see if we are right or wrong. Oh, we have already taken a number. So I'm sorry. Yeah. So 10, the answer is 2. Yeah. So let's put num here instead of 10. And comma. Then now I can check. say 1, 2, 3, 4, and 4 digits. So I think we are doing it correctly. We don't need this just yet. So digit count will count the number of digits. And in fact, we do need this. So let's do that quickly here. Let's get the output. So let me remove the output here. We don't need this. What we need though in our main program is D, the output from that function. So I'll say digit count. Input would be the num, and let's say we take the output as D. So whatever the number of digits are in num will be stored in this variable called D. All right, we've got this. We have counted the number of digits. Cool. Or just to be precise, let's not take it in D. Let's say POW for power. So this will be the power, raised to the power. So we'll be using this value somewhere in our further calculations. Cool. Now, since I know the number of digits, I can go ahead and do the rest of the uh, problem statement. And for that, I will have to basically extract again each digit from the given number. I will have to raise it to the power of the number of digits and keep adding it to a variable such that I get this final sum of all the digits raised to the power of the number of digits. So to do that, let me start with, let's say, a variable called sum. So I'll start with a variable called sum and I will start with sum is 0. All right. So the sum is 0 to begin with, and I will here need another loop because I want to continue this process of adding to this variable sum till I have counted all my digits. So again here I will give a condition where my input number is 0. So until my input number is 0, this loop will continue. And of course, because I will be making changes to this num, I later on, to see whether it is an Armstrong number or not, I will have to use this num. But since in this operation I am changing the value of num, I let me store this num in some other variable also. So let me take a variable, say uh, initial number, and I will set it because we will be changing the value of num. All right, cool. Now here I will do the following. First, I will take a variable, let us say I, and I will take the value of the remainder of num divided by 10, and for doing that I will use the modulo operator. So the modulo operator basically returns the remainder after num is divided by 10 or whatever value you put here. So let me put it as a comment here so that you understand better. So and modulo returns the remainder after division, and in our case it will return the last digit of the number. For example, if the number is 123, then 123 modulo 10 is 3. So if you divide 123 by 10, then the remainder is going to be 3. So I have my I, and now I will create another function to uh, okay, we don't need a function also really. All I will do here at these stages, since I have this I, what I do here is I will just do, and this is a crucial step. Sum is nothing but sum plus I raised to the power. We have POW as the number of digits, we have counted it. So whatever the last digit is that comes from this operation, I raise it to the power of the number of digits. And some of you may be confused with the use of the variable name. So let me make it D again so that you don't confuse it with power. And I will make this D. So I to the power D. And just so that uh, the caret sign here, it is allowed as far as Raptor goes, it's just raised to the power. So you can use the caret sign. And this will continue. But yes, of course, I will have to do one more step here. And that is I will have to set num back again to floor of num by 10. So once this is done, I can check my output for sum. So I can set it here. Let's say sum. Let me see if that answer is right or wrong. Let's take a simple example, 23, and the output is 13. The square of 2, because the digits are 2, so the square of 2, the original number was 23, the square of 2 is 4, square of 3 is 9, and 9 plus 3 is 13. So our logic is correct. We don't need this. All right, now we have our sum, which is basically the sum of all the digits raised to the power of the number of digits. And we have our original number, which I stored in a variable called initial number. And at this stage now, all I need to do now is to check if that initial number is equal to sum or not. If yes, then I can say, I can say as an output that the given number is a Armstrong number. Cool. And if no, then I can say it is not a Armstrong number. So let me just put is not a Armstrong number. All right, this is over. We have written the logic for Armstrong number with just one function here, dg count. And now if we want to check, I can check 153, and then it says given number is Armstrong. So we have done it right. So this is how you will build the logic to check if a given number is a Armstrong number or not. I hope this helps. Please follow me and keep doing these exercises, which I will be posting or creating from time to time to keep building your logic. We will move on to formal programming language very soon. I will create an entire series on that. We will see how to do more complex problems slowly, gradually. But this is like a course anybody can take or a journey anybody can take to just start learning how to program. So, yeah, so thank you for watching. See you in the next video.